So in this unit, we're going to be looking at an introduction to functions. So basically, if you look at the idea of a function on a graph, and this is not something you have to remember this year, this is a function because there's nowhere that I could draw a single vertical line that's ever going to hit that function in more than one place. So that one is a function. But if I have something like a parabola that opens to the left or to the right, that's not a function because I could draw a vertical line, and this x has two different y's with it. So that's going to hit that function or that relation in two places, so it's not really a function. We're going to focus right now on what the domain and range of a function or a relation is. What I want you to remember first is alphabetical order. Input comes alphabetically before output, and you should write this down. X comes alphabetically before Y, and domain comes alphabetically before range. So if they're talking about the domain of the function, it's the x values in the function. So if I look at this and they want me to list the domain from this table, now you need to do these brackets for set notation. I did that by like a forwards S followed by a backwards S. There are some students who do a C and then like a point and then a C. Whatever you need to do to get this bracket done. And then I'm just going to, domain says, hey, list out my x values. I want you to list them in order from least to greatest, and don't do any repeats. In this case, they already are in that order. So 1, 2, 3, and 4. That's the set for my domain. Now I'm only going to use this set notation, these brackets, on what are called discrete functions, and I'll talk about that in just a minute. My range is the set of all my y values. So that's going to be 6, 9, 14, and 21. Now again, my closing bracket for me, I do like a backwards S and then a forwards S. Some students do like a backwards C, point, another backwards C. Find the one that works better for you and use that. If, let's say I had another point in the middle here that was the point 5, 14. I would have put the 5 after the 4 in my domain because I want to list things in order. I would not have put the 14 down twice for my range. Just going to put the 14 once, but make sure I list them in order from least to greatest. Okay, one thing that will come up sometimes, this is the part that's not alphabetical order, but your input goes with your independent variable. Input, independent variable, which means your output goes with your dependent variable. Because y depends on x, the output depends on the input, the range depends on the domain if it's a function. So this, they could have also presented this as a graph. That's not a great graph, but let's say this is the 0.16 and 2.9 and 3.14 and 4.21. As long as I had a scale on here so I could find out what those points were, I still would have used these brackets for this because these points are separate from each other. They're distinct points, so I can tell this is a single x, single x, single x, single x, single y, single y, single y, single y, and I would have listed them out in this order anyway. These are called continuous functions because it's not just a set of totally separate points that you know, like this, where they're not connected. This is all connected. So on these, we're going to use what's called interval notation. Domain deals with my x's, and so I look, and the furthest left this goes is where x is 0. So 0 is less than or equal to x, which is less than or equal to, I look at this graph, and the furthest right this curve goes is 360. So when I'm looking at x, since x goes left and right, what's the furthest left that this goes? What's the furthest right? Those are going to give me these endpoints. Now just so you know, if there was, instead of this being a closed circle at the end, if they had done an open circle right here, it means it goes all the way up to that point, but it doesn't include it. So in that case, I would have had 0 is less than x, not with an equals because of the open circle. We're going to skip 4, we're going to do 3, and then I want you to add 2 more things in just a minute. So this is continuous because these points are all connected to each other. So I look at the furthest left this graph goes is 1. and the furthest right that it goes is 5. So my domain, x1, is less than or equal to x, which is less than or equal to 5. The range is y, so the furthest down this goes is 0 for y, and the furthest up this goes is 3. So 1 is less than or equal to y is less than or equal to 3. Now, there were a couple things that didn't show up on these, so I want you to turn your paper over, please, and put these two on the back. So we're going to say this is 5 and 6. For 5, I want you to just sketch a graph where at the point 2, 2, put a point, and then draw a parabola that opens down. It doesn't have to be gorgeous, it just opens down. And we're going to write the domain and range for that, because it opens up some things we haven't seen yet. Now, a parabola never becomes purely vertical. There's always some sideways movement. Even if it's pretty steep, it's always moving further left and further right the further down I go. And it never stops, which means eventually it's going to hit every x you could possibly name in the negative direction and every x you could possibly name in the positive direction. So since it goes infinitely in the negative x direction, my domain is negative infinity, which is like an 8 on its side, is less than or equal to x, which is less than or equal to, again, it goes infinitely in the positive direction, so positive infinity. Y, however, it keeps going down forever to negative infinity, less than or equal to y, less than or equal to, but here is the highest it ever goes. It never goes above this point, and that's where y is 2. So you're going to have some infinities in there as well. And then the last one I want you to draw, oh, well, that is so bad I'm going to have to undo that. The last one I want you to draw is sort of a vertical line. We're going to go over here to negative 2. We're going to draw a vertical line, but we're not going to include that one point on the axis. Everything on this line is included except this point. Well, my domain is all of the x values. Remember, domain comes before range, x comes before y. If I think of all the ordered pairs, negative 2, 1, negative 2, 2, negative 2, negative 12, all of my x's are negative 2. If that was a closed circle and that point was on this line, I would have said, hey, it's going to hit every value of y, all the way up to positive infinity and all the way down to negative infinity. Instead, though, I'm going to say negative infinity is less than or equal to y, which is less than or equal to positive infinity, but I'm going to put a semicolon, y cannot equal 0, because there's that open circle that says don't include this point where y is 0. Now, we're going to go back and look at 4. We have to make some assumptions or be given some information to probably do justice to this. So it says independent and dependent variables. Remember, the independent variable is the input, which is the x's. The dependent variable is the output, which is the y's. T-shirts sold to the freshman class. Well, we have 400-ish freshmen, so they might sell as many as 400. So my domain, now this is kind of wrong, but I'm going to put it down anyway and then talk about it. I could sell no T-shirts to the freshman class, or I could sell as many as 400 T-shirts to the freshman class if everyone bought them. The range being that the profit, if I don't sell any T-shirts and there were startup costs of $500, I'm out $500 and I have made no money. I've actually lost $500. But if I sell 400 shirts, I've got to figure out what the profit is per shirt. So let's assume that on each shirt, I can make $10. I sell them for more than $10, but I can make $10 on a shirt. So for 400 shirts, if I sold all 400, I would make 10 times 400, which is 4,000, but I'd still have to subtract out those first startup costs of 500. So 4,000 minus 500 is 3,500. These are actually not correct. I'll accept them in this case, but just so you know what this really should be, this is like the continuous thing where everything between those two is included. I can't sell half of a shirt or 2/3 of a shirt. I could only sell 0 shirts, 1 shirt, 2 shirts, 3, etc., 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 all the way up to 399 shirts, or at the very top, 400 shirts. So this is actually more accurate. And then my profit, if I sold 0 shirts, would be negative 500. And if I'm making a profit of $10 per shirt, this is just going to go up by 10. So negative 490, negative 480, dot, dot, dot just means the pattern continues in the same way until I get up to, if 3,500 is my top, then 3,490 would be the next to the last, and 3,500 would be the last. Okay, thanks guys.